Hi everyone, we're going to do two lessons today, lesson 4.5 and 4.6. So our first lesson today is about isosceles and equilateral triangles. So we're going to name a triangle according to the number of equal sides that the triangle has. So if there's no equal sides, we're going to just call this scaling. Now, something you need to know is that if there are no equal sides, that also means that there are no equal angles. So no equal angles. So all three angles have different measurements. Now, a little tidbit, the longer the side, like I can just look at this and tell this side here is the longest. Across from that is going to be the the biggest angle. And when I look at it, I can just visually see that's the smallest side. So across from it is going to be the smallest angle. So just a little tidbit that will come up in theorems later. Next, isosceles means, now this is maybe new, it has at least two equal sides. So if there are two equal sides, again, that means at least, that means it could have three. However many equal sides the diagram shows you, that means how many equal angles you have. So on this diagram alone, let's call these A, B, and C. If AB and BC are equal, then across from them are also equal. So angle A is across from BC is equal to across from AB, which is angle C. So two equal sides, two equal angles. And lastly, equilateral, that means all the angles are equal. So if all angles or all sides are equal, then that means all the angles are also equal. Okay, so we know all of these have to be the same. Now, when all the angles are the same, we have a name for that, and let's just jump down, and this is called equiangular. Now, every single time this happens, every angle is 60 degrees because 180 divided by 3 is 60. So anytime it's equilateral, it's automatically equiangular, and each angle is 60. Now, we have a name for when it's equilateral and equiangular, and that is called regular. So when it's both, again, we can just say it's regular. Now, we could also name it according to the angle measures. Now, when it has obtuse angles, it can only ever have one obtuse angle. It can't have two because remember, triangles add to 180 degrees. So if you have two angles that are more than 90, that automatically is more than 180 degrees. And if you try to draw it out, it just doesn't work. So again, if you have an angle that's more than 90, it's obtuse. If you have an angle that's equal to 90, it's a right triangle. And again, you can't have two right angles. Try to draw it. You can't draw a three-sided figure with two right angles. If all are acute, then it's an acute triangle. And technically, like this one here, it's acute, but it's also equiangular since they're all the same. So we're going to go through these and we're going to name it according to its sides and according to its angles. So let's always just do the sides first. On this one, I notice all three have different markings. So that is scaling and then the right angle. On this one, everything's equal, so it's equilateral. All the angles are equal, so it's equiangular. And again, we have a name for that. That is regular. Now we have another name. They're all acute. So this is also an acute triangle. Now, if there's nothing really marked, we just have to go by visually, okay? Now, first of all, I notice all the sides are different. So it's scaling. So we just need to look at it and determine if it's acute or if it's obtuse. And sometimes you can't go by picture. So I'm going to put an angle measure in here so we're 100% sure. And this is acute. And again, three different side lengths. So this is scaling. the right angle, so it's right. Now on this one, I have two equal sides. So this is isosceles, and technically these are both acute. And I think that's it. And I think F is the exact same picture, just rotated. So the same answers go to F, isosceles and acute. Now, you might be saying, how do we know they're acute? Again, I'm just going to put a little angle measure in here so there's no trying to disprove it. On this one, I'm going to say this is 100 degrees. So now we know this is isosceles and obtuse. All right, theorem 9. If two sides of a triangle are equal, all right, this is, again, what we were kind of talking about before. If two sides are equal, then the angles opposite them are equal. So here's a little trick. If I say, what's opposite AB? Opposite AB is C. So there's only 3 letters. So if you have AB here, across from it is the other letter, which is C. So across would be angle C. So what's across from BC? It's the other letter. What letter are we not using? That's angle A. So according to this theorem, it says if two sides are equal, the angles opposite them are equal. So we know angle A is equal to angle C. The corollary to theorem 9, equilateral triangle and equilateral triangles also equal angular. So if all the sides are the same, that means all the angles are the same. Now, if you look at the corollary down here, they're very similar. You just have to see what comes first. On this one, they're told that you have all the sides are equal first. So this is kind of like your if. So then you know all the angles are equal. Now, for theorem 10, the corollary, we know all these angles are equal. So then we know all the sides are equal. So that's the difference. Now, theorem 9 and theorem 10 are also very similar because on theorem 9, this is if two angles are equal. So these angles are given first. So we need to know what's opposite. So what's opposite A? Well, use the other 2 letters. The other 2 letters are B, C. And what's opposite C? Well, let's use the other 2 letters, which is AB. I shouldn't say equal. Let's do an arrow. So I know AB is equal to BC, according to theorem 10. So these are usually very tricky. You guys have a theorem sheet, so always reference it until you remember. Theorem 9 always talks about the sides first, and the corollary talks about the sides first. But theorem 10 talks about the angles first, and the corollary talks about the angles first. So it's sides and then the angles. Okay, now for SSS congruence, this is just another way to prove triangles are congruent. It's the easiest one. If all the sides of one triangle are congruent to all the sides of the second triangle, then the 2 triangles are congruent with each other. All right, so I'm just going to attempt to draw a couple of pictures here. Actually, let's do this way. I know these 2 are equal and these 2 are equal. I'm not even going to rotate them or anything. Now, D, E, F. Okay, so on this triangle, if we have corresponding sides that are equal, so we know that triangle ABC is going to be congruent to triangle DEF because of side, side, side. And you should understand what that means because we already have proven SAS and ASA. So this is just another easy way to do this. Which of the following is not possible? All right, obtuse isosceles. All right, so this can be 100, but these 2 sides can be still be the same, so that works. Acute isosceles. Well, these 2 could be really tiny. and these could be the same. So that works. So it's down to these two. Can we have obtuse equilateral or acute equilateral? Well, when you have equilateral triangles, we've already talked about these angles are always the same. They're always 60. So that's acute. So the one that's not possible, you can't have an obtuse equilateral. So that is your answer. And we're going to finish today with a flow proof. C is the midpoint of AD. So let's put that on the diagram. AB is equal to BD. And then I see BD here is a reflexive side. Now, when you do these flow proofs, remember there's always 3 steps going down. And it doesn't matter the order that you do them in as long as you have all the steps. C is the midpoint. This is given. Now, I'm not finished because I didn't prove anything equal. Now, since I know that's the midpoint, I know AC is equal to CD. Definition of midpoint. I'm finished with this step now since I know 2 things that are equal. A given statement is AB is equal to BD, and this is given. And I'm finished because 2 things are equal, and BC is equal to BC. And again, this is not almost wrote given. This is reflexive. Okay, so I'm just going to bring everything together and I want to write a congruency statement. Remember, the first triangle, the order doesn't matter. So I'm going to say ABC, use a congruent symbol, and then DBC, and then underneath you tell me how. Well, this was side, side, side. And then lastly, we're going to say I'm proving angle A and angle D are equal by CPCTE. If you look at the diagram, these 2 are corresponding and equal. Now today is one of the only days we've had to double up on assignments. You're going to do 2 online assignments, lesson 4.5 and 4.6. All right, good job. Message me if you have any questions. Next class is a review and the class after is your test. Bye.